Assalamualaikum. Hi guys. In this video, I'm going to explain another example for limiting reactant. In the previous video, we've learned how to determine the limiting reactant through calculation based on general unknown. But right now, I'm going to be more specific with a general equation for reaction of sodium metal with oxygen gas. What you have here is this equation, and you got the information given for mass of sodium metal and mass of oxygen gas. So the first question asks you, what is the limiting reactant? Then you have to calculate the mass of your product, Na2O, and last but not least, calculate the mass of excess reactant remain by the end of the reaction. If you realize, the style of question for limiting reactant usually the same one. The difference only based on equation that you have. So I hope you can memorize or understand the technique and the tips that I'm going to share you based on this video. Let's go to the solution for this question A, where you have your equation. Check first whether that equation is balanced or not. So what you have here is 4 sodium, you have 4 sodium, and then you have 2 oxygen, you have 2 oxygen. So it's balanced. So my question, which is the limiting reactant? So I'm going to continue with taking out the information. You have the mass for sodium metal, and you have the mass for oxygen gas. So the one that I taught you before in the previous video, if you want to determine which question you need to find out the limiting reactant, if you got this kind of case, both reactants can be determined based on their number of mole, automatically that question will be related to the limiting reactant. So let's go to the step 1. Step 1, you have to find the moles for both reactants. Due to the information in mass, so you have to calculate based on the formula mass over molar mass for number of mole. So I'm going to do one by one. Calculate the mole of Na. You will have 0.6522 mole for the mole given or mole available. Next one, you have the second reactant, oxygen, which will be the number of mole 0.9375 mole. This is also mole available. Now we go to the second step. You have to do the stoichiometry and pick which reactant you want to set as X. So I'm going to choose O2 in this case as my X. So you can see that from balance equation, 4 moles of sodium reacts with 1 mole of oxygen. And the second line, you got mole available for sodium, which is this value, and you want to find out mole needed for oxygen. So I will have 0.1631 mole for oxygen gas. So this is the mole needed. Now let's continue with step number 3. You have to deduce which one is the limiting reactant. So I'm going to compare my mole needed and mole available for my X, which is O2. So you can say that mole of O2 needed is less than mole of O2 available. So in conclusion, you can say that oxygen is the excess reactant. But you cannot stop here because the one that I asked for is limiting reactant. So automatically put the sentence sodium is the limiting reactant. So this is where stoichiometry is very helpful to determine the limiting reactant. Now let's go to question B. I want you to calculate the mass of Na2O produced. So this is your product, which is at the right side. As usual, my tips here, you have to do the stoichiometry by comparing with limiting reactant. And please use the mole available for the limiting reactant. My answers from previous question, sodium is the limiting reactant. So I have mole available for sodium which is 0.6522 mole, I'm going to do my stoichiometry between limiting reactant sodium metal with my product sodium oxide. So let's continue with my stoichiometry. From balance equation, I have 4 mole Na produce 2 mole of Na2O. So the one that I have mole available, X is the one that I want to find out mole needed. So rearrange, you will have 0.3261 mole of Na2O. So this is mole for your product. But the question asks you about mass of product. So you have to calculate the final calculation mass of my product. So the final answer will be 20.2182 gram. So I hope you can understand the relationship between moles of product with the limiting reactant, because it is consumed completely by the end of the reaction. Let's continue with question C. I have here is what I have here. I need to calculate the mass of excess reactant remain at the end of the reaction. So the same tips given, always compare with the limiting reactant. So from my previous question, I have O2 is an excess reactant. So you can see from here, this is mole available for O2. So I'm going to show the stoichiometry again so that I will have another mark for this one. If you realize, this stoichiometry is just the same as question A, but please, you need to copy it back at question C as you want to get full mark. So continue with this, you will have mole of O2, which will be 0.1631, and this is mole needed. Next one, to calculate the excess reactant, you have to compare between their mole. So this is the formula where you have to find out mole excess of O2, which will be 0.7744 mole. This is mole remain at the end of the reaction. So from here, I'm going to continue with the mass of O2 remain, where you have your number of mole times with molar mass of O2. The final value will be 24.7808 gram. I leave it try this 4 and try this 5 so that you can enhance your understanding based on this video. That's it for now. I'll see you in the next one. Bye!